Welcome to today's Dlubal webinar. Today we present the add-on module RF-Stages that can be used for the consideration of construction stages. My name is Gerlin Schubert, but I'm just a moderator today. More important today are my two colleagues, Wieland Götzler and Adrian Langhammer. Wieland will explain the features of the RF-Stages module and will present an example in RFM where you can easily follow what is happening and how the calculation works. Adrian will answer all your questions that you can ask via the chat option. Both are responsible for the RF-Stages module. Here you see the control panel from the GoToWebinar software. That's quite easy to handle. So you have the orange button up here, the orange arrow where you can show and hide the control panel, and you can use the chat option down here to ask your questions. Please keep the questions short, and we try to answer all your questions during the webinar. And just in case there are too many questions coming in, you definitely get an answer, but it might be via email after the webinar. So please be patient. So that's already all from my side. I hand over to Wieland now, and enjoy the webinar.
So welcome on board today's webinar about our stages module. And first of all, I would like to give you some background information about stages calculation itself. It might be new for some of our listeners today. So at first, we want to take a look at an easy example. It's from a conference dated in 2008 of these two guys, Mr. Bischoff and Mr. Bletzinger. Calculation on the whole model and what possibilities, and yeah, that's what it was about. And on the slide you can see on the left side simplified high-rise building. It's 10 stories, and on the left side the ceiling slabs are connected to line supports, rigid line supports, and this is the connection to the, let's say, rigid and stiff core of the building, like the elevator or something like this. And on the outside of the building you see the slender columns, and simplified structure looks like this. So we have a surface load on the ceiling slabs, we have slender columns, they are connected via hinges, and on the left side it's a rigid line support. So if you would calculate this model in RFM as the whole model, it will look like the left graphic, and there you can see construction stages are not taken into account. So there's just one calculation for the whole building. All the 10 stories are calculated in just one step with all the 10 surface loads. And you can see in the graphic of deformations, in the results there, you can see that the deformations are increasing to the top of the building. That means we have the minimum deformation on the bottom, we have a maximum on the top in the red color. And this is like a hang-up effect of the ceiling surfaces. So there's an addition of deformation from the bottom to the top, and you will find the maximum bending moment and the maximum deformation on top. The question is that calculation representing the real behavior of the build-up process or the real behavior of the structure? And it is clear that the whole model, the whole building, the 10 stories are not built just in 1 second or one step. They will be built step by step. That means first there will be, of course, the first story, then the next one, and so on. So the problem is that this stages construction is not part of the whole calculation, and this leads to wrong results. So on the right side you can see a calculation with RF-Stages, where you can take the construction stages, the whole build-up process into account, and you will see that the maximum deformation is more in the center of the height of the building and not on top of the building. So you can, I modeled this construction stages as this. We have a first stage for the first story, and then the second stage for the next one, and so on. And what happens in RF-Stages module is that the deformation of every stage, that means the local deformation of the outer columns, this is compensated between the construction stages. That means the two columns at the beginning of stage 2, they are like extended at the beginning of the calculation, and then there will be a deformation in that direction. And then it will be compensated again and again. So this is what happens in the real build-up process, because otherwise you will like preparing the Tower of Pisa, and there will be an addition of deformations of all the construction stages like on the left side. Another fact is that you have a decreasing of the deformations. In this example, it's about -24%. The maximum deformation is just 2.9 millimeters compared to the 3.8 millimeters on the left side. This is, of course, just an theoretical example, but 25% less deformation is quite a lot, and you will get also less bending moments. And as you can see on the right side, they are definitely on a on another place instead of the top of the building. So with this information about the construction stages calculation, we want to take a look at the features of RF-Stages in the next slide. What are the features of stages? Of course, you can add, remove elements. That means, as I did in the example of the high-rise building, you can add columns and surfaces and even solid elements in several stages. You can remove them, like for temporary columns, just in the first stage or second, whatever. You can remove these, or you can even modify elements. You can modify materials, hinges, and even supports. You can also take nonlinear elements into account. That means you can follow tension elements, you can follow compression elements, and these, because in RF-Stages the several stages are calculated by Newton-Raphson, and for a combination in a separate specific stage you can use temporary loads. That's the next point in this slide. What does it mean? For example, you have a temporary load like a crane or something like this in stage number 2, representing some construction workers or construction truck maybe, and you want to inspect a combination of different positions of this load. So this is what you can do with temporary loads, and these are acting only in the stage and not in a following stage. These temporary loads are calculated by first order, and that's why you can you can combine them as a result combination in a particular stage. What else? You can define the position of a new element in RF-Stages. That means you can use tangential position for a new element. This is important for bridges construction, or you can use the original position of RFM, like for the high-rise building in the example before. You can show the deformations as a sum of deformations or as a particular deformation in the separate stage. That's what I want to show you after this slide in a small example. And of course, you can export these results to RFM as a result combination to use it for a design or for printing the results for a later analysis. So with these features, we want to move over to RFM, and there I've already created a small model for today's webinar. We have a small building, concrete and steel. We have 3 surfaces. a lot of concrete columns over there, and we have also temporary columns over there, these two steel columns and a small temporary platform. I already created the load cases. It means we have build-up loads for stage 1, stage 2, and stage 3. And as you can see, it's an important fact that you have to split up the loads for the stages calculation. So I want to prepare 3 stages. That means the first stage, the bottom of the building, then the next stage will be added in stage 2, and then the final stage where I want to remove the temporary frame over there. And in the second stage, I already will remove these 2 temporary columns. So important is to split up the loads. This is built up for stage 1, stage 2, and stage 3. And we have also mounting loads. These are the temporary loads on our platform. So right now we want to start with the module RF-Stages. By double-click on this module, over there you will find general data, and it is just about to define the stages. So we have 3 stages over there. You can write down a description, or you can use a template like construction stage 1, 2, and stage 3. And then we can go on to members dialog, where you have to add the members which are will be added or removed or modified in the particular stage. In stage 1, of course, you cannot modify or delete something or remove something because there's no stage before stage 1. So we will start to add something, and these are all the columns over there and the 3 horizontal steel beams. Okay. In the next stage, we want to add not these columns, but these members. Okay. And we want to remove the 2 temporary columns at the bottom of the building. Okay. And in the last stage, we build up the concrete columns in the 3rd floor and remove the temporary frame over there. So as you can see in the graphic, you can follow the selection in the RFM background. So construction stage 1, 2, and 3. Now we want to add the surfaces. So that's quite easy. Stage 1, surface 1, stage 2, surface number 2. And in the last stage, there's the roof surface. Okay. We don't have any solids in this model, so we can go on to the nodal supports, and we will just select all of them. Okay. We don't have to remove the nodal supports because the member, these intermediate, these temporary columns will be removed, so there will be no load left to this one, and we can just leave it as it is for all the stages. We don't have any line supports, either surface supports, so we can just go on to the loads. And in RF-Stages, it is possible, as you can see in this mask, to add permanent or temporary loads. The permanent loads are, for example, self-weight, or any kind of load case or load combination which should be taken into account in every stage. So it is a constant load for all the stages, like build-up loads and live loads. Yeah. In this example, I created load combinations for the several stages, and you can also use for example, load cases or load combinations, or you can even use them together. Yeah. So in stage 1, I prepared a load combination number 1, so I can add this over there. Stage 2, loading for stage 2 as a combination, and stage number 3. What about the self-weight? Self-weight is a special type of load in RF-Stages. You can add the self-weight as a separate load case for every stage. So in this example, I could create 3 load cases of self-weight, but this is quite time-consuming, and in this combination there is no self-weight active because we can use the assign self-weight to all stages checkbox over there, and because I used partial safety factors in the load combinations, I want to change the factor in the self-weight 2 to 1.35, for example. Okay. On the lower left side, you can find this alignment of new elements like initial position, which is exactly the same as an RFM, or tangential position, which is the position of a new element in relation to the last or to the last stage before, which might be more important for our bridges construction. Okay. What else? We have 2 mounting load cases over there, and these should act only in the separate load stage. So I will add this load case number 6, mounting stage 1, as a temporary load case for stage 1, and mounting stage 2 as a temporary load case in the second construction stage. To combine more than one load case, you could use temporary loads, but in our example we have just one mounting load case over there, so I will just add it by a factor of 1.5, for example, for construction stage 1, and then the next one for stage 2 also as a factor of 1.5, load case 7. And with this definitions, we can start the calculation. And you can see that there's a separate calculation for each construction stage. And after that, all these results are combined together as an envelope of all construction stages. So you can check the results like in RFM in several tables, results, Nodal Supports, for example. Construction stage 1, you can check the temporary load cases and an envelope of all the construction stages, including temporary construction stages. So right now I could do just nothing with these results. I can do no design because they are just in the module, and to export them to RFM, you can easily click on the export button, exit the module, and you will get result combinations in RFM. Right now we can just stay in the module and check the results in the graphic. So on the right side you'll find a panel with the envelope, or you can take a look at one PLC, which is the permanent load case, permanent loads for stage 1. We can take a closer look to the structure over there, and you can see that there was a temporary steel column, and there are no deformations over there. In the next stage, this column is removed. It's in the background right now. You cannot select anything, and you can see a deformation which is on the ceiling in the second stage. You can check the normal forces in the temporary frame over there, and in the third stage you can see that also this frame is in the background. It's grayed out, so there's nothing. It's removed in the last stage, and this is like the final result or final stage. Yeah. I've also I talked about a feature to show the deformation, type of deformation, that means an undeformed system or in the particular stage. So if I want to know what or how many or what size of deformation is in the last stage in the structure, I can change this option to in particular stage, and you can see that in the last stage you get an additional deformation of 15.6 millimeters on the structure, and on undeformed system it's 46.1 for the first floor. That means the total deformation of this surface is about 5 centimeters, but in the particular stage, in the last stage, it is just 50 millimeters. All right. Right now I can do a small design with these result combinations of RF-Stages, for example, in steel members module. And you can use these combinations over there, or you can just use the envelope to get a small elastic stress design, for example, for these columns. First of all, I have to switch off the partial view mode to get these columns working. Cancel. Okay. Incorrect. So this is stages. Okay, now I can use it in RF steel members module, and I can add these columns for design. For example, these two temporary columns, and I want to check the envelope of all the construction stages on these columns. Therefore, I will change the method of stress calculation for result combinations to stresses from internal forces and run the small design, and it's just about 7%. Okay, with this small example, I want to close the presentation, and I will hand over to my colleague, Gerlin Schubert, for some additional information for you.
Many thanks, Wieland, for the informative presentation. I hope that you all found it useful. I also saw my colleague Adrian working hard answering all your questions. Many thanks to him. When there are still open questions, you can write us an email or give us a call. Here you find all the details, email address and phone numbers. You can always have a look on our website for more information about the several add-on modules. And there are upcoming webinars very soon in March. We have 2 webinars about the data exchange between CAD work and HSB CAD and RFM. So for those who are working with timber constructions, this might be interesting. There you see it on the website, and you can register using this link. So you go to support and learning, and then to webinars under there. So on the 30th of March and on the 31st of March, next webinars are coming. So I thank you very much for your attending. I just double check if Adrian is still answering something. So that's all done for today. Thanks a lot, and bye-bye.